Hi everyone, welcome back to the channel. So today in this video lecture we're going to be solving the same single source shortest path problem with Dijkstra algorithm with the implementation where we will be using set instead of priority queue to store the pairs. The pairs represents the distance node pairs which are sorted in increasing order according to the distance from the source node. So here in this graph we have a graph of 6 vertices numbered from 1 to 6 where node number 1 is the source vertex and all other nodes have a distance of infinity because they haven't been visited yet. Now I want to find the single source shortest path for every node of the graph starting from the node number 1 as the source node. Okay, so we'll be using set instead of priority queue. So we'll be discussing why we are using set, how it is better, if it is better or not, whether it is better or not. We'll discuss all of those things in this video lecture. So let's see the set implementation. So what we're going to do is we'll be using set where we use priority queue. So initially we have source node as node number 1. So we take a distance array as we do in the Dijkstra algorithm. We have a distance array. The distance array is numbered like this. So initially we are standing on source node which is node number 1 and we'll initialize it with 0. All other nodes are initialized with a very large number. Let's call it infinity, where this goes up to, let's say, 10 raised to the power 9. Okay, something like this. Now here in this set, let's push the source node which is node number 1 along with its distance which is 0. Okay, now iterate till this set is not empty. Pop the top node from the set which is this one, the pair which has a distance as 0 and the node as 1. Now this is the pair that we have 0 1, and for node number 1 traverse its adjacent nodes, that will be node number 6, 3 and 2. Okay, so let's go to node number 2 and try to update its distance. So we know the equation. It's basically if the distance for the node where we are going, or let's call it 2, the node where we are going, the equation like this. Now the entire array is initialized with a very large number. Now put infinity. So now update the distance of node number 2, that would be 0 plus 7 which is 7. 7 is better than infinity. So reinitialize the distance for node number 2 to be 7. Do the same for node number 6, that is 0 plus 14 is 14 which is better than infinity. So put 14 here. Then go to 3 and again update. 0 plus 9 is 9 which is better than infinity. Again it would be 9. So we'll also push these pairs into the set. So we'll push 6 along with its updated distance, that is 14. Then we'll push 3 with its updated distance as 9. Also push 2 with its updated distance as 7. Fine, so we have pairs like this, and out of these pairs pick, this is deleted. This pair was deleted from the set. Now we have these 3 pairs. Pick the pair, pick the node with the least distance from the source vertex. That is this node number 2. We can see that node number 2 is nearest to the node number 1. It has a distance of 7. So we pick this node. Now from node number 2 traverse the adjacent nodes, that would be node number 3 and node number 4. So traverse node number 3, the distance would be 7 plus 10. 7 is the distance for 2 here. 7 plus 10 would be 17. 17 is not better than 9. So we're not going to update the distance of node number 3. Then we traverse node number 4. Its distance will become 7 for 2 plus 15 is this edge weight, that is going to give me 22, which is better than infinity. So we'll update node number 4 with 22. So we'll push node number 4 into the set with its distance to be 22. So this set basically sorts these pairs according to their distances in the ascending order. Okay. Now here, now we'll again pick the node from this set which has the least distance. That would be node number 3 here. Its distance is 9 units, and from node number 3 I can move to 6, 4 and 2. Okay, so let's try to move. We will not be able to update the distance for node number 2 because for node number 2 it would be 9 for node number 3 plus 10, that is 19, which is not better than the distance which you already have, that is 7. Then we move to node number 6, its distance would be 9 plus this edge weight, that is 2, 9 plus 2, 11. So 11 is better than 14. For node number 6 we have 14, but if I traverse node number 6 through this node 3, that is, this is the path which I am taking from node number 1 to node number 3, then from 3 to 6, the weight would be 9 plus 2, that is 11. So for node number 6 I would update it to be 11. So but I already have node number 6 here, you can see that. So here what I do in priority queue, if it would have been a priority queue, I would have pushed like this 6, and then I would have pushed its distance, newly updated distance, to be 11, while this entry I had to put it as it is. In case of priority queue, I put both entries in it. But since I'm using set, what I will do, I can see that this 11 is a better answer than the answer which I already had in the distance array. I'm gonna delete this entry from the set because set supports erase operation. Set support erase operation. And its complexity is log n, where n is the size of the set. That means whenever I find a node with a better distance, so whenever I have a node with a better distance and there is an entry for the same node in the set, that means if I already have an integer not equal to this infinity into this distance array, that means this integer is present in the set, and hence first I will erase that pair corresponding to that node, then I will push the new pair for that node with the newly updated distance. Like here in this case, before I push 6 into the set, I will erase this from the set, then I will be pushing 6 along with its distance. Now that's the idea. So I have traversed node number 6, then I will traverse node number 4, and the distance for node number 4 will become 9 plus 11, that is 20. Is 20 better than the distance which I already have in the array? Yes, 20 is better. So we'll update 20, we'll update the distance for node number 4 here, and we can see that we had 22 here. That means we already updated the distance for node number 4 at least once. So we have an entry corresponding to node number 4 in the set here. That means first I will erase this entry, then I will push this node with the newly updated distance here. That's the idea. Then from here, from node number, so I have traversed node number 6, 2 and 4. Now again from these entries, I will pick out the entry with the nearest distance, with the smallest distance from the source vertex. That would be this node number 6. So I will pull node number 6 from the set, and I will update the distances for its neighbor nodes. That would be node number 5. Okay, so for node number 5, the distance would be, for 6 we have 11. So 11 plus 9 would be 20. So is 20 better than the distance which I already have in the, for the 5? Yes, we have infinity for the 5. So 20 is better than infinity. So I'll update the distance for 5 to be 20. And I will push this node into the set. Its distance is 20. Then I will traverse node number 3. So 14 plus, for node number 6 we have 11. that is this path, so it would be worse if I traverse node number 3 again. So that's all. Then from these entries, now we have only 2 entries remaining in the set. I will pick this one, node number 4. So I will update its neighbors. So its neighbor is node number 5. So for node number 4 the distance is 20. So 20 plus 6 is 20. 26. Is 26 better than 20? No. That means I will not update the distance for node number 5. Same goes for node number 3. I will not update the distance for node number 3 because it would be 20 plus 11, that is 31. I will not do it for 2 as well because 20 plus 15 is 35. So I will delete this entry. Then I will pick node number 5 from this set here and delete its entry from the set. And for node number 5 we have distance as 20, the updated distance, and I will try to traverse its adjacent nodes, that will be node number 4 and node number 6. I will try to update their distances. For node number 6 it would give me 20 plus 6, 20 plus 9, that is 29, but we already have a better distance for node number 6, that is 11. So we're not going to update the distance for node number 6. Same goes for node number 4. The distance for node number 4 that we have is 20, but through node number 5 it would be 20 plus 6, that is 26. So we will not update the distance for node number 4 as well. So that's all. That's my final distance array prepared. So what is the difference between this approach and the approach with priority queue? Just this erase function. While using priority queue, I'm gonna push the duplicate entries for a particular node, and I have to iterate over all of those entries one by one. So I will be doing redundant iterations. Okay, that's the problem with priority queue. But here I don't have to do those redundant iterations for any node. I just have to pull a given node exactly once from the set. And because whenever I'm updating the distance for any node which I already have in the set, I'm going to erase it first, then I'm going to push the result into the set. So in this fashion, this node, this is working. So let's just see the implementation of this approach in programming language. So we'll be implementing this approach using C++ language. Okay, so let's just create the function. Let's create the class solution. So in this class, let's create the function that is, let's say we have this function returns a vector which contains the distance for each node from the source vertex. So let's call it Dijkstra, and this function takes in the number of nodes and the adjacency list. Declare the distance array with the size n plus 1 and initialize it with a very large number. So let's say infinity is 10 raised to the power 9. Okay, now declare a set of pairs and initialize the distance for the source vertex. So we also have a source vertex in this function with 0, and push this source vertex into the set along with its distance. So we're gonna push this source vertex. Now till this set is not empty, I'm gonna iterate over it, and I will be st dot, so it would be like st dot So let's put P here. So we'll erase this pair. Now I will check if the distance for this node, that is P dot second, this is going. So let's check if the distance for the second node is already better than the distance which this pair is offering, that is P dot first. If it is the case, then just continue right from here. Now iterate over the adjacent nodes, that is ADJ P dot second, and check if the distance for this node, that is the adjacent node where we are going, so check if there is a scope for relaxation. So if there is a scope for relaxation, then I'm going to check if this distance that I have for this node it dot first, if it is not equals to the distance which I initialized it with, if it is not equals to the infinity, in that case we already had an entry in the set for this node, so we have to erase that entry first. So first erase that entry it dot first for this adjacent node, that would be distance it dot first and it dot first. Okay, and after erasing the entry, update the distance for this node to this new distance P dot first plus it dot second, and push this node into the set, push this new pair into the set, that is distance it dot first and the node itself. Fine. At the end, when this while loop ends, then return the distance array from here. So in this fashion, this function is working. It will give me the shortest distance till all nodes of the graph starting from the source vertex, and that's the implementation in C++. So which approach is better, using set or using priority queue? It depends upon the other factors as well, like which type of graph we are using. We have sparse graph, we have dense graph, and so on and so forth. We have to consider those things to understand which approach is better. Is it better to use set or a priority queue? There is a little difference between the time complexity of these two approaches, so we can't say that set is better than priority queue or priority queue is better than set. It depends upon other constraints of the problem as well. Okay, so we'll discuss those constraints in the next video of this series. We'll be discussing a few more optimizations of Dijkstra algorithm, and we'll also discuss a bit about the set versus priority queue dilemma. And that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel, and stay tuned with me in this series where we'll be solving a lot of problems based on Dijkstra algorithm, and I hope to see you all in my next video.